Perfect. All right. Given that it's almost time, like 1 minute off, I might bring myself onto screen, which is fantastic. Thank you for joining. We'll be starting shortly. Welcome to the webinar. Forward. My name's Jasmine. I'm a course advisor at West Perth, which is fantastic. And we'll just go. So please turn off notifications during the webinar using, sorry, just bear with me. This will get rid of any distractions on the screen. You'll be able to turn them on once we've concluded the webinar. This will help avoiding any disturbances during the presentation. And please note there that you can see how to do it on, we've given you a bit of a instruction manual, which is fantastic. So just take a moment whilst everyone's doing that. Perfect. Okay.
It's okay now? Yeah, I think I turned off the notification.
That's good. That's good. Okay. So just some common questions. As of the certificates of attendance, the link will be provided at the end of the webinar. Once you complete a short survey, please note the process is automated, so please ensure to provide us with the correct details. This will ensure that your information is correct when you get the certificate, which is quite important. This certificate will be sent from the webinar team. So we'll include the recording as well as PDF slides. This will be sent by the marketing team, which will be sent to the same email that you registered with. This will be sent within the next 2 business days. Please ensure to monitor your junk folder just in case. And then, so I think that covers everything there, which is great. So just a bit about EIT. So EIT is a specialized engineering education provider, which is fantastic. We go from anything from professional certificates all the way up to a doctorate of engineering, which is amazing. So that's your advanced diplomas as well. We are industry orientated, and that's because we just do engineering, which is amazing. We have very experienced industry lecturers as well as just overall academics, which is awesome. Sorry about that. And then, so this is just a few, this is from a survey that we did I think it was last year at some point. And that's just to discover why students choose EIT. This was done by our students. We weren't really involved. We just sort of distributed it throughout, which was amazing. Now these are a few awards that we won, which is amazing. So we won one in the 2024 Australian Export Award for International Education and Training, and then we won the Export Award for International Education and Training again, which is amazing, but on a larger scale. I believe that was compared to other states as well. So just going to welcome, I'm going to remove myself on screen. And we'll be beginning the performance-based design for beginners, basic concepts and applications. Dr. Abate will be presenting now. Thank you.
Thank you so much. Welcome, webinars, and we appreciate that you made it today. And today we are going to discuss the most hot topic, performance-based design for beginners. And if you want to know more about me, you can scan this barcode and you can see here. So the agenda today, which we would like to discuss, is about performance-based design. And mostly this webinar will be software-based, but we will start with the basics of performance-based design, and the agenda will include structural modeling for PBD, what is PBD, including material properties, section definition, again, lateral load and performance objectives as per FEMA 356 and ASCE 4117, pushover analysis, what is pushover and step-by-step implementation, evaluating structural performance, what is retrofitting, and overview of performance-based design principle, focusing on structural behavior, nonlinearity. PBD differs from traditional prescriptive methods and why it's essential. So as you can see, we have a broad topic, but we will try to make it systematic. So the last 4 years, we as EIT, we did research papers, and to know more about PBD, what is performance-based design, and other more, if you want to have more in-depth knowledge about PBD, we published this paper as the sample research paper, which is published the last 4 years with Dr. Anna Evangelista and Professor Vivier Tam. So I invite you to read these papers, okay? And it will give you the more idea, okay? And the first webinar also here, if you want to know about linear analysis, okay? Linear analysis, you can see our first webinar here. So let me focus on this global research trend in the performance-based structural design, a comprehensive bibliometric analysis. This paper, if you see here, the awareness of performance-based design.
Sorry to interrupt.
Okay.
Just let me know when you need me to change the slides. Sorry.
Yeah, but okay. I have the option also. Okay. Thank you so much, Jasmine. I really appreciate it. Okay. So as you can see, the awareness of performance-based design increased from 1981 until 2023. As you can see, the graph was increasing. And in this bibliometric analysis paper, we try to see, we try to examine around 3,469 PBD related papers. And in this research, the awareness of performance-based is increasing, and we try to see which journal was publishing more in the PBD approach, engineering structures, and in the country-wise, United States was, the leading publisher, as you can see, United States, and co-occurrence also, all key words and analysis result also checked, and performance-based design word, the keyword was used more frequently. So mostly in the research, in the literature review, what we saw was in the context of seismic hazard assessment, engineering design and comprehensive understanding of local geological and geophysical factor is very essential. And previous studies also lack these crucial components such as local soil condition, ground response analysis, topography influence, active fault characteristics like slip rates, groundwater behavior, and slope consideration. And to ensure the accuracy of seismic hazard map of a country for the safe, cost-effective design, engineering structure in an urban area, the detailed analysis is required, okay? So the problem is because of lack of these elements, most countries, their seismic hazard map is not accurate. So in general, from the literature review, there is one hypothesis. It's not a hypothesis, but some idea what is the challenge of adopting seismic design code without necessary adjustment, accompanied by the absence of reliable seismic map in the country without earthquake recording stations, may lead to structural failure. In such context, performance-based design emerges as a viable and crucial solution for ensuring the structural integrity and safety for existing and newly constructed structures. Basically, the summary of if you see the literature review in this, if you want to summarize, code-based design cannot address earthquake design issues. This is the first. PBD is a cutting-edge seismic design technology, and the effect of using the prescribed adopted code without amendment and design approach focusing on force are not adequate. The shortcoming of seismic hazard maps. PBD was introduced in the United States, and how the earthquake in eastern Japan also alert Kenyans to assess their building codes, and still in Korea, the use of PBD is in its infant level. And why do different country code differs from each other? For example, if you design your building with Eurocode and ACI code, the result is not the same. So these kind of things, lack of expertise and awareness of PBD. Overall, this study provides a comprehensive overview of the research on the performance-based design and identifies the key research topic and future direction for future exploration in the PBD area. So in general, now you can ask questions like, does the absence of earthquake recording station and reliable seismic data pose a significant challenge for the country without the means to generate accurate seismic hazard map? This is the first question. If you are a structural engineer and if you don't have reliable seismic hazard map, that is a significant challenge. Again, if we cannot trust our current seismic hazard map, can we rely on structural design using it? Because if it is not reliable, how can you design with it? The answer is evidently no. So this raises the question, how can we design structure that perform well in the future unexpected earthquake? This is a question without reliable seismic hazard map. Consider the absence of valuable seismic map in certain country. Could performance-based be valuable solution? This is also another question. And you can go through like the seismic performance of informed concrete design according to this. Is this effective or not? Again, the most important thing is, as you can see here, we have two types of analysis, like linear and non-linear analysis, depending on the geometry and depending on the application of load, we have static and dynamic load. So if it is linear static, we have equivalent lateral force procedure and we have response spectrum procedure. We have modal response is 3 times 3, and we have, again, linear response times 3 analysis. And non-linear static analysis, we have pushover analysis and non-linear times 3 analysis and non-linear response history analysis. For your information, today, we're going to have a software demonstration, including all these analysis types, okay? So as you know, response spectrum uses the idea of mode shape and it will use the result using SRSS and other techniques, but mostly response spectrum is like pseudo dynamic analysis. It is between dynamic and static. That's why it is here in the middle, okay? But time history analysis, we have to extract real ground motion from international recognized database like USGS and peer websites. We have to generate, we have to download past earthquake record stations to perform time history analysis, both linear time history as well as this one. The last one is the same as time history. This is response history analysis to find the solution of the governing equation of motion instead of using the concept of mode gaze and response spectrum and mode shapes. We are going to use direct a step-by-step direct integration technique to find the response of our structure. Okay, we can use Newmark's method or Rankuta and other type of this one. So the pushover is, you know, where we have a lot of pushover, first mode dominant and multi-mode, but we're going to use, I will show you that one also. In the linear this one, linear modal response history, we are going to use also in a linear model. So how to change linear model to nonlinear also, we will see, okay? So in general, we are going to use this one. So as you can see in EIT, okay? In EIT, we use 44 in the 100-story building, okay? 44 in 100-story building. And this is what we did, okay? We changed the model from linear to nonlinear model, and we apply all the analysis types, and we apply classical model analysis, response spectrum analysis, linear time history analysis, pushover, and nonlinear time history analysis in all linear, and in the linear model, and in the linear model, we apply nonlinear time history analysis and pushover analysis. So this is just general simple 44 and 100 story, and this is the oh, okay, I don't know. Can you check, please? You cannot see someone is asking, they are not seeing the slide. Jasmine, can you hear me? Can I proceed or?
Yes, yes.
Okay.
Just regarding that person, please log out and then log back in to the webinar.
Okay. Great. Okay, thank you, Jasmine. So as you can see, this is the detail of the 44-story and 100-story building, and the material property, load type, modulus of elasticity, and everything you can give, like you can check in our first webinar. This is elastic analysis, and the material is the same. And as you can see, we have all the classical model analysis, equivalent lateral force procedure, response spectrum analysis, linear time history analysis, and pushover analysis, and nonlinear time history analysis. So the pushover in nonlinear time history analysis is applied in the nonlinear model, and the others, these are applied in the linear model, in the both 44 and 100 story. So the first cycle is you just apply load and check the global and local responses of the linear model, okay? Then you have to find story displacement, story shear, story drift, story stiffness, story moment. And the second is just apply nonlinear time history analysis in the nonlinear model and check also the global response, story moment, story shear, everything, and check the results from linear and the nonlinear. I will come there, but this is the response spectrum, how you can define response spectrum in different codes, okay? So you will compare now linear and nonlinear, okay? This is the cycle 3. Then after you compare, okay, if, for example, if the comparison of cross-section and area of reinforcement is equal, no problem, no need to go to the next step. But it's no, then you have to go to the next step. Then what we are going to do, we are going to design our response with the optimized nonlinear time history analysis result and pushover analysis. So we have to optimize our the final local and global response found in the pushover in nonlinear time history analysis. As I told you, the peer ground motion database, we extract 11 databases like earthquake, past record earthquake, for example, Imperial Valley in the US, Lenders in the US, Mamos Lake, and all this earthquake was happened, for example, Imperial Valley, it was happened in 1979. And record station 164, magnitude 653, and VS30, where the shear wave velocity 471, PGA value 0.1, and the mechanism was strike slip and special ordinate. This was SRSS type. So as per the code, we need minimum 11, okay? We need 11 earthquake for linear time history analysis, as well as nonlinear time history analysis and pushover analysis. So for the linear analysis, we have to use linear model, and for the nonlinear analysis, we have to use nonlinear model. So I will show you how to scaling and matching of this earthquake, okay, to the target response spectrum of your site, because we cannot use this response spectrum, because if you see the time history, for example, this one is for 60-second earthquake, and the peak ground acceleration and the magnitude is not the same as your target response spectrum. So you have to like this. For example, scaling and matching of, we can use two softwares. We have Seismomatch, and ETABS itself has the capability of matching your target response spectrum with the ground acceleration. For example, this one is RSN 100. So we have to bring the downloaded earthquake data, and you have to match it. And as per the code, from time period 0.5t until 1.5t, the matched response spectrum should be at least 1.3 up to 1.4% higher than your target response spectrum. So you have to take care when you download these earthquakes. You cannot simply download this earthquake. You have to check the type of earthquake, the fault type, whether it's pulse type or some. There is a lot of criteria, because the earthquake which you are downloading should be the same as your site, and you have to use a technique called deaggregation. Okay, this deaggregation information, it will give you which earthquake contribute more about your fault. Okay, so you have to check in that area. This is also the same matching and this scaling in the ETABS, and I'll show you in the minute. Okay, after that, this is mode 1, mode 2, mode 3, and after your analysis without applying your loads, you have to check classical modal analysis, because the first two modes should be translational and the third should be torsional. Okay, this is as per code requirement. Now the question is my structure safe? For example, if you are a structural engineer, you know that the hazard came from, for example, from earth. We have earthquake, we have volcano, and a lot of actions. And from water, from fire, we have a lot of. So as you can see, disaster is hazard plus times vulnerability times exposure. So as much as possible, we have to this risk. We have to minimize the risk. So building codes. It's good, but because we are transforming our perspective from code-based to performance-based. As you can see, building is the code. They will give us like a specific requirement, give us acceptable solutions, prescribe, for example, procedures, rules, limits. They are like rules you have to follow. So a structural engineer should follow the code. The spirit and the idea is good, but they have a lot of wrong assumptions. So modern codes, how they are working, as you can see here, for example, if you are a structural engineer, now you are doing linear analysis. For example, if the owner asks you, will the building will be safe? Will the building collapse? Will it be damaged? Can I use the building after a given earthquake? How much will the repairing cost? How long it will take to repair? Can I make a building that will not be damaged and will not collapse? Then the structural engineer always say not sure, because I'm just following the code. Okay, if you are a structural engineer, you are simply following the code. So if the client asks you these questions, you will not answer anything. What is a because you are following this one. The code is using this capacity demand. Yes. So if DCR, for example, if the demand is greater than okay, DC ratio greater than 1, then it is unsafe. It is it's less than 1, it is safe. So this is the only thing all codes are using. Okay, you are using also factors and something, but this is only criteria. And don't forget this one. As per, if you are using linear analysis, you don't have any option to check the limit of you're building this question. You cannot respond at that time. Why? Because, for example, demand and capacity, even when in the code case, when you use the DC ratio, even the demand side and the capacity sides they have a lot of factors. Even you are not using the unchanged DC ratio. Okay, even in the demand ratio, load cases, load patterns analysis, while you are doing a lot of things, you are adding a lot of factors and something like that. So DC ratios are a lot of factors, and it will not give you the. So as I told you, design for safety against, we will see all these procedures. Okay, I will show you in a minute. So The idea of code-based, now this is a key point. The idea of code-based is, for example, this is your wind load, then apply safety factor, and this is your design load, okay? Then we have DBE level here. Before DBE level, we have MC level. So you cannot design MC level. If you think your structure is, if your structure is like linear analysis, it will be very costly. You cannot design with linear analysis. So what the code recommend, then we have to make 2/3 of MEC level, then we will come to DBE level, yeah? Then again, in the DBE level, as you can see, we cannot design. So what the code recommend us is we decrease from DBE level to design level with R factor, as you can see, you see? Then this R factor is considering for the ductility and overstrength factor, because once until this point, the yield point, then this is not straight line. This is not because of ductility, and it is also increasing. This is increasing because of the overstrength omega factor. So as you can see, the omega factor, we use omega factor again once we decrease all the structure to inelastic response using R factor. Then what we are doing is some structures, okay, some building structures, for example, girder beams and other things, you want them to stay in elastic range, yeah? So you have to increase them also with omega factor, over strength factor. So if you see this gray area, all are very random. That means R can vary from 1.5 to 8 and omega can vary from 1.5 to 3. So this area is just a guess, okay? It is a guess. You are doing your structure with guess. So the PBD, what PBD is saying is that instead of guessing, okay, instead of using R factor, omega factor, CD factor, all these kind of factors, okay, why don't you use this one? Just get your force deformation curve, the real strength of your material, okay? Instead of relying on R factor or something, just get your material, go to your laboratory and get the force deformation stress strain curve of your material for steel, for concrete, and know your strengths, okay? Know your capacity. Then check your structure with MC level, okay? And check with service level. Then you will see with your requirement, okay? You will check how your building will perform. That is it, okay? You design your building with design level, and you're gonna check with MC and service level. This is how performance-based is working. No need to rely on codes, R factor or something, okay? You have to rely on your actual strengths of your material. So as you can see, the progress of the building, intuitive first, it was intuitive design, then we come to code-based design, the performance-based design, then the consequence and risk-based design, then now in the resilience-based design. So as I told you now here, what you have to do is just get your curve for concrete and for steel, get your stress strain curve, and you know the real capacity of your section, your section, then this is your material. Then you apply the plastic hinge and fiber hinge modeling in your linear model. Then you know the capacity, then apply your force, then check whether the force applied in your structure pass your capacity or not. So you have to check your demanded capacity curve. This is how performance-based are working. So the performance-based design process, let me give you very quickly what you are going to do. First, you have architectural design and primarily design detail, yeah? Because everything starts from architecture. Then what you are going to do, the structural engineer will have linear elastic modeling, okay? You have elastic modeling, linear. Then what you do, code-based design, as you know, you can do whether ELF design or response spectrum can do the job for you, okay? Because this is linear elastic modeling. Then you have to determine the capacity of all elements. Once you finish the elastic design, then it will give you the cross-section and area of steel. Then using the cross-section and area of steel, you know the capacity of your section, column section, big section, and everything. Then change the elastic model into non-linear modeling. Now, when I say nonlinear modeling, we have a lot of principles in the nonlinear modeling. Like, for example, continuum modeling, we have fiber hinge modeling, and we have plastic hinge modeling. So you have to choose which kind of model, nonlinear modeling you have to use. For our model, what we use is we use fiber hinge modeling for shear wall, and we use plastic hinge modeling for column and beam. Okay, so what is plastic hinge modeling? I will show you. Okay, it will give the depending on the capacity which you finish here. Depending on that, you have to give the capacity in the beam and column and the shear wall sections. And anywhere you want to make ductile, you have to give it, okay? Then you have to change your nonlinear model from linear model. I will show you also here. And then apply response spectrum for, this is response spectra for service level and MEC. Don't forget, for performance check, we will use service level and MC level as we have seen here. Here we have seen here. Let me show you here. We have to check the MC level and service level. But the design level in the elastic, it will done in the design level. So we will make, okay, then modification of ground motion and a lot of issues, because how to convert the real ground motion, as we have seen from peer website or something, you will extract ground motions and you have to match it to your response spectrum, okay, target response spectrum. Then service level evaluation using linear model is okay, because when you check service level, you can use linear with response spectrum analysis, but MC level, you have to use nonlinear model and nonlinear time history analysis. Then the performance assessment for both service level and MC level will be checked. If it is okay, then finish. If it is not okay, you have to change the design, repeat again here, because you have to come and change the linear elastic analysis, and you have to do. This is the most important thing you have to. If you want to know the performance-based design, this is the procedure, but it has a lot of critical points you have to know. What is nonlinear modeling? What is plastic hinge modeling? What is fiber hinge modeling? What is continuum? Nonlinear model types, and this kind of, it's not easy. I will show you in a moment, okay? And after that, we have different levels like operational level, immediate occupancy, life safety, and collapse prevention, as you can see, depending on the level, okay? Depending on the level, because once you have the force deformation curve of the capacity side, then you can give percentage for IO level, this life safety level, collapse prevention. Because once you finish 99% of the capacity of your the curve, okay, once you give the capacity side.
Sorry to interrupt again. I'm just wondering what slide you're on.
34.
34.
Yeah.
Okay, so it's not been changing it on this one as you've been going through, which is not ideal, but that's okay.
Let me share my screen.
Yeah.
Huh? It's better, yeah?
Yeah.
Let me share?
Yeah.
Okay. Let me share my screen. Window. Share content. I think the screen or window.
You should be able to, through the sharing, there should be PowerPoint Live.
Screen, it says screen.
Okay.
Wait, no. Stop sharing. Let me go. I think let me make Windows. Can you see anything now?
I can see you, but that's about it. I'll reshare it. But just when you're changing slides, let me know, so then I can change it for you. So 34, that's the one you were up to?
Yeah.
Okay. It's all right. Can everyone see that?
Yeah.
Perfect. Okay, fantastic.
Okay, great.
Awesome. Thank you.
Okay, thank you, Jasmine. So as you can see here, we have the key performance indicator to consider. For example, we have the stiffness, stability, strength, deformation, drift, ductility damage, and damping, energy dissipation, and acceleration. So the key performance indicator can be evaluated based on the nonlinear analysis we perform. This means we have explicit performance limit that client or government, this performance based, there is a lot of guidelines I will show you in the minute. You have to know the performance level. For example, if the client wants his building in the immediate occupancy level, then it should be in the immediate. If it is life safety, it's collapse prevention, it should be in the collapse. Again, in each stage, you should know the limit, okay? You should know the limit. For example, stiffness. For example, story drift, it should not be past 2% or 2.5%, something like that, okay? So you have to first have a performance based, okay? You have to agree with the consultant, with the client and the PBD specialist, the acceptable performance indicators, okay? Then it should be in that limit. So this is the PBD and linear dynamic modeling background. And as we have discussed now, we have performance-based design in one end, and we have the building code in the other end. So this is the advantage and disadvantage you can go through, but just for your information, for example, prescribe specific criteria and procedure that design and construction must conform to. Engineers do not actually evaluate the ability of the structure to perform as intended by the building code and something like that. But if you see the PBD, then overcomes the shortcoming of building code for seismic design in which the performance objectives are considered implicitly and guarantees the safer building, which better reliably by explicit evaluation of the structural performance and under different level of earthquakes and to substantiate expectation to specific prescribed code requirements. Okay, so this is some of the advantages of the performance base to substantiate this expectation to specific prescribed code requirement, use of seismic force resistance system, and innovate design not prescribed by code, and provide cost-effective designs. So each level has its own requirement. Okay, now we are page 37. Okay, we are in the page 37. And as you can see, we have operational level, immediate occupancy, life safety, and collapse prevention. For example, what you expect in the operational level. For example, if you are in the operational level, negligible structural and non-structural damage, and occupants are safe during event, and utilities are available and facilities are available for immediate for use, and loss is less than 5%. This is the occupational. Immediate occupancy, we have negligible structural damage, occupant safe during event, and minor non-structural element, okay, in the immediate occupancy, and building is safe to occupy immediately after, and limited interruption of operation. This is less than 50% of damage is expected. Life safety, significant structural damage and some injuries may occur, and extensive non-structural damage, building not safe for reoccupant, and the damage is like 30%. In the collapse prevention, we have extensive near collapse, structural and non-structural damage, significant potential injuries, but not wide-scale loss of life, and extended loss of use. Repair may not be practical, and greater than 30% of loss will appear. So we have three types of earthquakes, as you know, service level, okay, 50%, and probability of accident in 30 years. And DB level, we have 10% of probability in 50 years, and the maximum considered earthquake, we have 2% probability of accidents in 50 years. As you can see, as I told you now, DB is in the code-based, okay? In the code-based. We design our building elastic code here, and then we will check for performance evaluation, service level, and MC level. So as you can see here, we have service level earthquake here, we have DB level here, and we have MC level here. So we will design our building with DB level, and we will check it for MC level and service level. So what you expect, for example, level of earthquake, as we have seen now, what is service level and what is maximum considered earthquake. And as you can see, 50% of probabilities are tiers, and the damping is 1.5 until 2.5 you can use in the service level. And this is for the MC level. You can go ahead and PBD procedure, it will have geometrical evaluation, then probability seismic hazard assessment, schematic design, wind tunnel test, and other design. This is the information which you need when you start PBD. So in the service level evaluation, for example, what you expect? You use only linear model and response spectrum analysis, and acceptable criteria are not considered in serviceability evaluation. Accidental eccentricity 5% is not included, and critical damping generally 1.5 2.5, and load combination is normal load combination like dead load plus live load, and seismic 100% and 30% in X and in Y. Okay, like that. And MC level also we have like this, and you are expected to use 2.4%, and I will come in a minute. If you see here, for example, acceptance criteria, member strength DC ratio 1.5, this is for deformation control, and like 0.7 for control. Okay, and as you can see for the story drift, 0.5 is recommended. So this is classification of component. We have deformation control and force control. If it is deformation controlled, it's not like shear, okay, failure. It is ductile. We have overstrengths, and we have ductility factor, and you can see they are different. This is hysteresis loop we are using. We have different kind of hysteresis loops, and the loading and unloading curve you have to give, because when you give the capacity of your structure, you are expected to give the backbone of your curve, not only the backbone of your curve. We need the dynamic analysis hysteresis loop, and the loading unloading rule also should be given into your structure. Okay, but we will come in a minute. So this is for force deformation. This is the deformation control, and this is force control. Okay. Now this is nonlinear fiber modeling. As I try to show you, if it is, for example, this is the confinement effect. If your structure is not confined properly, the ductility will have a lot of effect, okay? Your capacity, because if you see this, the red one is the confined one, but this one is unconfined one. So confinement is very important. We are in 42, page 42. Sorry for the inconvenience, okay? And this is nonlinear fiber modeling. And what we are, this one is the MC level requirement. For example, peak transient means the first few seconds drift not exceeding 3%, and maximum drift shall not exceed 4.5%. Residual drift, maximum of mean value shall not exceed 1%, and maximum drift shall not exceed 1 point. We have a lot of different, I will show you, especially ASCE 4170 limits. I will show you the standard. It will give you all the acceptance criteria for each MC level and DB level. So you can go ahead and see, for example, shear wall shear. And if you see here, shear wall reinforcement axial strain should not pass 0.05% in tension, 0.02 in compression. So you have to follow this acceptance criteria. This is the same acceptance criteria for different levels, service level, MC level, and DB level, as we have seen now. So this is the most important. I am in page 45. So the most important guideline, ASCE 4170 modeling parameter and numerical acceptance. It will give you...
Sorry to interrupt. Please,
yes,
when you change slides, let me know so then I change it for the viewers.
Okay. Okay.
Thank you.
And yeah, even I was trying to share my screen. I don't know, instead of screen, because I have to show them the software also. So let me check window maybe.
Okay.
Let me check window. Can you see now? Can you see my window? Wait.
I can, just on a different screen. One person has said no.
Can you try now? Can you see now?
This,
But
unfortunately,
please tell us, can you see my screen?
okay, I think I'll share it again, and there might be an option for you to take control. Just bear with me
Yeah,
one moment.
because I have to show them software also in the minute.
Yeah. Which slide was it? It was it 45?
Yeah.
And then on your
Yeah, this
screen,
is
there should
45.
be a few dots, and then have a look to see if you can take control.
Manage slide only me, view slide high contrast, translate slide. This is the 3 option I have. Manage slide only for me.
Manage slides, yeah.
Let me click. Jasmine?
Yep.
Okay, let me check.
And then now try changing slides.
Okay. It's okay now?
Which page are you on at the moment?
46. Someone says it's fine.
I'm still on 45, so I'm not too sure.
Then Gideon Coffee, something he says 45.
Seeing 45 as well, so just let me know when you change slides and then I will change it, but otherwise...
Abate?
Sorry?
My apologies, it's Tibiso. Could you please take control of the slides on the top left-hand side, just next to the pop-out window? You can take control from there and then you can actually move the slides. Additionally, for the users, they can also click on sync to the presenter in order to sync their slides, their screens with your slides. Otherwise, it might be a network issue. The slides have been moving, but right now we're currently on 45. So I would like for you to take control of the screen so that Jasmine doesn't move it for you because you want to show your software. So please take control and then tell us when you're moving screens so we can confirm.
Okay, can you tell me the instruction again? Which way, where we go? I go to more?
Okay, so there's more. No, you move from more, you go to the left-hand side. I wouldn't know if it has to be your left though. So yes, so you move to take control, click on take control, and then you'll be able to control your slides. You have been doing that, but I think we lost connectivity for a short time, which is why they were not syncing. But Jasmine is asking that you just click.
Okay.
Yes.
Yeah. Okay, I click take control now.
Okay, move the slides so that I'm aware that you're moving them and that our listeners are also able to see that you are taking control of the slides.
You see?
There you go. You're on 46, right?
Yes.
Perfect. Thank you so much, Dr. Abate. Thank you so much, Jasmine. Guys, please confirm if you're on slide 46 or 45, if you saw that movement so that we can continue with the presentation.
Yeah, but how can I make it bigger? For me, it becomes very small. Wait, increase font size? I don't know. Wait. It's very small for me.
On your end? Okay, just a moment, please.
Can I share?
Would you like
my
to
screen?
share?
Because if I share, then it's easy for me. I can present from my end. So when I share, it's a screen or window?
Okay, so right now what we're doing, we're sharing from the PowerPoint presentation through PowerPoint Live. But you do have the option to share your screen. Please share your screen with us, and then we can make sure that our viewers are able to see it just as well.
Okay, this is a screen. For example, this is my screen.
Okay, we can see you on 2 screens right now.
But I want to share the window, not my screen. Wait. Share window. For example, let me share this one. There
we go. We can see your window as well as your presentation. Is that good for you? But it's not coming up for us. Just a moment.
For me also, it's not. It comes now.
Okay, ladies and gentlemen, I've just made the presentation on screen. Please tell me if you're able to see. Additionally, you are going to receive all the slides as well as this recording sent to your mailboxes no later than today. I do see Kurzan saying that they are able to see. Okay, there we go. Happy days. You may continue, Dr. Abate. Apologies for the delay. However, I am glad that you guys are able to see the screen right now. Thank you so much for your patience, guys. Dr. Abate, you may go ahead.
Okay, so okay, this is the ASCE 41 modeling parameter in numerical acceptance, and as you can see from the sheet, the guides, there are a lot of international guidelines they will give you, okay, for the IO, LS, and CP acceptance criteria, as you can see. So what you need from your IND is the capacity, because as you can see, it is very small for me now, but you have to know the cross-section of your beam, and you have to know the cross-section of your column. And as per the amount of rebar, you have to come here, and whether you see, if you can see here, see, this means conforming and non-conforming, you can go ahead and you can read down, and it will give you, they will give you the acceptance criteria, IO, LS, and CP level, okay, in the end. So how can I go to the next slide?
You just click on the left-hand side of your presentation. Just click on the slide that you want to go on to, Dr. Abate. So just click on 46 there, on slide 46 on the left-hand
Okay.
side. Yes.
But it is stuck. It's stuck. I don't know. It's stuck.
Okay. Just a moment, please. Okay, I'm going to ask to share the presentation on my end again, and then you will take control of the slides that I am going to share. Ladies and gentlemen, again, I really do apologize for the delay. However, we really do want you to see the software that Dr. Abate is talking about. So it really will take some trial and error. Please receive our apologies for this. Okay, please take control again, Mr. Salasi.
Oh. Okay, I take control already.
Okay, yes, you have taken control. I can see that. Unfortunately, you have to do it manually, though. You have to go to slide 46 by clicking on that arrow. It takes a long time, but I think we will go there. Just continue clicking. Or would you rather I do it? Can I take control and move for you quickly? And then you'll take control again. I can move quicker through the slides for us.
Let me go, or you will?
Yes, I am moving right now, and then I am going to tell you once I'm on slide 46 so that you have access to your presentation again, and then you can continue.
Great. Yeah, I'm in page 20 now. Okay.
Okay, I'm the one moving the slides, so we are on page 46 right now. Are you seeing page 46 up in your screen, Mr. Salasi?
Okay.
Okay, are you all good?
Now 38. Can you go?
No, I'm the one who's doing it.
Yeah. I'm in 38 now.
Are you all good now, Dr. Abate?
I'm in 38. Okay, now 46. Great.
Okay, you're good.
So let me take control now. Now let me take control.
You have taken control, actually. I'm just going to ask, ladies and gentlemen, are you seeing slide 46 that is up on your screen, please?
Yes.
Okay,
Yeah.
happy
Thank
days,
you.
guys. I'm glad we're back on track. I will see you. Actually, you'll speak to Jasmine, not to me. I'll let the presentation continue. Apologies for the delay. Thank you so much.
Okay. Thank you. We really appreciate. So, sorry guys for the inconvenience. So as you can see, this picture will give you just visualization. What is rotation, for example, 0.01 means, and what is for example, here in the guide, as I told you, IO, LS, and CP, they have in the moment curvature, okay, moment rotation part, they are 0.01, 0.02. So the guidelines they are giving you in this form. So you have to sense it. What is 0.01? What is 0.02? What is 0.05? What is 0.06? So this means, for example, if it is rotation is 0.01, your structure is not that much cracked. If it is 0.02, as you can see, you have hair crack here. If it is 0.05, almost in both end it is cracked, and 0.06, it is almost in the collapse in the CP level. Okay, so at least it will give you idea. This was done in the laboratory UCL report. Okay, and this is the methodology for pushover. We have a lot of techniques, for example, capacity spectrum techniques, and we have displacement coefficient method to check the capacity of your building. In the pushover analysis, we have a lot of techniques. This needs a lot of time. Just for your information, okay? You can check FEMA 414 proved non-static pushover and the modal pushover analysis, and we have uncoupled modal participation. Again, this is the typical PVD review objectives. We have discussed we start from elastic analysis to non-elastic analysis, and we check the building, okay? The performance. Then this is the guidelines. We have Applied this Technology Council, we have FEMA, we have National Emergency Hazard Reduction, TBIs, and ASCE 41 guide. So when you are in PBD, you have to be very follow these guidelines. And this is how to assign. I will show you in the minute the fibers, how you can assign fiber modeling approach for your column. And this is for PM-M3 for walls, and M3 hinges for beam, and PM3 for walls, and PM2M3 for beams for columns. This is pushover load case. We will see it in the minute, okay, in the software demonstration. This is hinge assignment. When you assign the hinge, you have to know your force deformation curve, okay? Because if you don't know the capacity, from where you get your capacity? We have seen in the ASCE 4117, they will give you the IO, LS, and CP levels of your, as per your capacity, okay? Once you finish your linear analysis, then you know the section, the cross section of your beam and column, and you know the area of steel, yeah? Using this information, then you can come in identify your capacity, force deformation. This is force, this moment in rotation form, and you have to assign it in your nonlinear model. Okay, that's how we are going to do. Okay, then before I go that this is for column. For column, we have three options, because you know, to know the force deformation curve of column, you need biaxial, because we have PM to M3 combination, yes? So when you apply the axial load, the plane will have a lot of different angles, okay? So to identify the force deformation curve of your column, you should know exactly the M2 and M3 angle. So we have a lot of planes. So that's why in ETABS, it will give us the moment M2, M3, and we have three options, okay? And this is for your information. Now, at this point, when you are in the code base, when someone asks you, will the building will be safe? Will the building collapse? Will it damage? Can I use the building after given earthquake? How much it will cost? All these questions, the structural engineer were not able to answer. But when you come to performance based, yes, you can answer, because you know which level your building will be safe. Immediate occupancy, life safety, collapse prevention. Will the building collapse or not? You can answer now. can use the building after given earthquake? You can answer now whether it is in the life safety, immediate occupancy, or CP level, or something like that. So how long it will take to repair, how much cost it will, all these things will be answered. So from transforming yourself from the performance, the PVD, this the code-based, when you come to performance-based design, now you are not sheltering here, okay? Now you have full control in your building. So that is the most important thing. And PVD is not done by one person. It is a very long process. So the architects, sorry.
Sorry to
Yes.
interrupt again. I'm just wondering what slide you're on.
53.
53. Okay. I'm just going to ask everyone else to put in the chat what
50.
slide they're on at the moment, just because I feel it's not changed.
46.
46.
It's
Okay.
unfortunate.
It is.
Sorry, guys. They're in 46. I'm in 53 now.
53. Okay, it's still appearing as 46. So I might. Okay, it's just changed.
I've just taken control, Jazz. I think it would be better if you take control and
Yeah.
Dr. Abata will just tell you to move through as he continues with the presentation.
Yeah, absolutely. Thank you.
Okay, thank you guys.
Just bear with me one moment.
Okay.
So 40. What number was that again? Sorry.
56, something like that. 53.
56.
53, yeah.
53. Okay. Beautiful. Thank you.
53. Now I am in. Okay, great. Thank you, guys. We really apologize for the inconvenience. Okay, so everybody can see now. 53. Great. Okay, great. Thank you so much. So how PVD work, as I told you, it will start from the client and from architecture, structural engineer, then we have PVD specialist, then site-specific consultant, and PVD reviewers. So all these are working as PVD. So you cannot do it by yourself for proposing the acceptance criteria. The client also, he should agree and something like that. So when we have to start with the client, okay? If the client asks what is the benefit of applying PVD, if he asks now, any structural engineer, if you are following now this presentation, if someone asks you that if you design my building and if it fails, you will take responsibility. Now ask yourself, okay, can you say okay, or you will say no, I am following the code, and if the earthquake comes and the building fail, then it's not my responsibility. So as a structural engineer, we don't like that. When you are in the performance-based design, you have to take full responsibility and you have to give full information about the building for your clients, okay? And you have to tell him which how the building will behave in the future earthquake, okay? So the client will ask you, what is the benefit of applying PVD for me? Then our response should be, your building will achieve higher end certified performance compared to buildings that do not follow PVD approach. In addition, you will receive performance guarantee and certificate from the design consultant. So the design consultant will take 100% responsibility for the design, okay? So you cannot say I'm using just code and if the earthquake magnitude 4.4 or 5 comes and it fails. You cannot say that, okay? You have to show the client how the building will behave in the future for magnitude 6, magnitude 7, magnitude 8, and you have to tell him, okay? Yeah. Yes, I'll demonstrate everything. So this is a performance-based, this is what we do. This is sample example in your ETABS presentation, as you can see.
Sorry.
For each, yeah.
Have you changed
50,
slides?
yeah, 55.
Okay, please let me know when you're changing slides.
Okay, 55. Now it's okay?
Yep, I'm on 55 now. Just let me know when you go to 56 and then the following
Great.
slides as well. Thank you.
Okay. So this one is hinge result. Okay, once you give the force deformation, the capacity in your model, in the nonlinear model, after your analysis is completed, you have a chance to see whether the capacity of your hinge pass the yield point or not. As you can see now here, this is the first given the capacity of your backbone curve. Okay, it is given. For example, this is the result of hinge response, this one. So as you can see, it will show you whether your hinge pass the yield point or not, whether it is in the IO, LS or something, okay? You have to check this. It will give you after this one, okay? Jasmine, so shall I change or you will change for me?
I have changed. Thank you.
Oh, 56. Could you please go to 56, please?
Yep. Thank you. We are now on 56. I'll be changing it from here onwards, so just let me know. Thank you.
Yeah, for me it is still in 55.
You will have to manually change it on your end.
No.
This is
Okay,
just for the
great.
viewers. Yep, thank you.
Okay, great. Now this is 56 again. As you can see, this is some of the results you will see. And after your analysis, once you give the exact force deformation curve in your building and you change linear analysis, linear model into nonlinear model, and you give the force deformation curve, after you analyze, it will give you the local response like this, okay? This is some of the examples of whether your building has IO level, LS level, and CP level. This is the research we did in AIT for our doctorate. Okay, so shall I go now? Next page, please.
Thank you.
Shall I pass?
$57.
57.
Perfect.
Okay, great. I also change it, okay? So I am in 57 now. So as you can see here, the stress strain curve for concrete is given already like this, and stress strain for steel also given like this. Then IOLA CP level as per your deformation curve from different guidelines or from lab report, you know. So when you apply the demand, when the earthquake comes, it will push your structure to the limit. Then you have a chance to see whether your local responses pass the given capacity. Okay, shall we pass to the next page, please? Great. Okay, so this one also the story, global responses you see, whether it is shear force, moment, story drift, story forces, and everything you will see like this, okay? So this is nonlinear times 3 result from ETABS. Okay, great. So can we go to the next page, please? This page is only, I want to show you the result. Okay, 59. Then this one is for performance level. Once you finish the nonlinear times 3 analysis DC ratio, then what you can do, you can see your performance level as per, for example, you can fix your DC ratio for immediate occupancy and you will check, okay? Then as you can see here, for example, DC ratio for immediate occupancy, okay? This one is DC ratio for life safety. And this one is DC ratio for collapse prevention. So in this way, it will give you different levels, okay? And you can see here, for example, this is for IO level, this is immediate occupancy and collapse prevention, and the software will give you the performance level. Okay, can we go to the next page, please?
I've changed pages. Thank you.
Great, great. 60. Okay, this one also the same thing. Okay, this is also the same thing. The DC ratios 400-story building, and you will get a luxury to see your building performance like this. Okay, can we go to the next page, please? Okay, this is the overall discussion on two linear analysis procedures, and we perform all linear dynamic time tree analysis, response spectrum analysis, and nonlinear time tree analysis and pushover analysis, and we get the result. Okay, for 44 and 100 story, this is sample results. Shall I go to the next page, please?
Sorry,
So I
there
will
is
show you.
a question in the Q&A section.
Which section?
The Q&A section.
Yeah, every question we will answer in the Q&A section, okay? No problem. So this presentation is just for your information, a general idea, but I will open the ETABS software and I will show you very quickly what I mean by performance-based design, okay? So shall we continue? Jasmine.
Yep, absolutely. Are you on slide 62 or 61?
Now it is 62.
Yep, perfect.
And okay, this is just the result we get from the analysis. As you can see, we have linear time tree analysis, response spectrum analysis, and pushover analysis, and linear time tree analysis. So we compare the results, okay? We compare the result in one graph, and we can see the nonlinear time tree is superior than the linear analysis, and the optimization of our overall structure is done based on the nonlinear time tree analysis and pushover analysis. So I think this is enough about the theoretical part. And Jasmine, can I share my window now? Because I want to I want to go directly to ETABS.
Certainly. Thank you.
So can you see my screen? Yeah, I don't think so. I have to share, yeah?
Yep, absolutely.
Let me share. But what can I say, screen or the window? I have two options only. I am confused. Include sound and side by side, report, control screen. If I share a screen, okay, let me check screen. But screen is not, it doesn't give me any option of sharing my, wait, let me share my window. Window, share window, okay, great. Share window, performance design, okay. I think it will help us now. Okay, can you see now? Jasmine.
Sorry, just bear with me one moment. I can see your screen there, but I can't actually see anything on the screen as of yet.
Did you see ETABS? Did you see the ETABS?
No, we cannot, Dr. Abate. The screen is completely blank. You have shared it, however, there's no content on there.
Wait, you will need to go back to window. You will share to, you will need to go back to the window you were sharing to resume. This one? Sharing is paused. You will need to go back to window you were sharing to resume. Okay, let me share window and this one. Oh, sorry. I think it came now.
Yes. It is on the screen. I've just put it on the screen. Please start the presentation.
Yeah, but this one, I want to share my window, you know, because I want to show them this one share only because I want to share my Wait. Include sound to this one. It should wait. I don't know how can I share my window. Someone says I can see it, but okay, wait. Can anybody see the ETABS now?
Yes, we can see the ETABS. I've brought it up on the screen, but however, I'm not sure what. Yes, we can see it.
Waiting. Someone says waiting in the lobby, but anybody can see now the ETABS software.
Yes, we're seeing it right now.
Okay, great. So I can continue, yeah?
Yes, please continue. We have run over time actually, so yes, you can continue.
Okay, guys. So this is, the software. Okay. So first, because we don't have time now, let me show you. Let's say this is your, this is your elastic modeling. Elastic modeling means you go to just section, okay, definition, you can go to frame section and you can define your sections, okay, here like this. For example, if you want to beam, you just go there and you put the beam section and everything, okay, the depths, the widths, and something like that. So in this way, you have to design your elastic analysis, okay? In the elastic analysis, you define material properties and you define the section properties like frame section, slab section, wall section, and everything, okay? So this one in our webinar, in the first webinar, we did it. I thought we have time and I'm going to show you, but let me go back. And for response spectrum, you go here and you have to define your response spectrum as per the code, okay? And once you have your response spectrum, then you go mass source. You're gonna go here and you have the mass source, okay? Whether spatial load or you can go to element and you can give the mass source. Once you do this, then the load cases, as you can see, I give all the load cases. We have dead load, live load, and the equivalent lateral force procedure. As you can see, the linear static force procedure, I give load pattern, okay? I gave load pattern, and we have in the X, in the Y, then we have response spectrum also, you see, in the X and in the Y, and we have earthquake, and we have time history analysis. What I want to show you here is, in the time history analysis, you have to give U1 and U2, okay? Then you have to, of course, if you go here, define load cases. If you go here, you have to define, for example, in the function times 3. And if I show you 1 times 3, for example, modify, this is, I'm modifying, this is the response spectrum, this RSM Imperial Valley earthquake, okay? Then you have to bring it into your software, and this is the time, okay? And once you bring it here, if you want to view, for example, the earthquake data, which is extracted from peer website, what you can do, you see, this is the earthquake data. For example, this is peer website database. It was in 1979.
Sorry to interrupt. It stopped
Yes.
sharing, unfortunately.
It stopped?
Yeah.
Stopped.
You just need to
let
share
me
your
share
screen
again.
again. Thank you.
Okay. It came now, guys.
Yes, I believe
Great. Can you see it now?
I can.
Great.
Thank you so much for that.
Okay, great. So once your definition is completed and the load case and everything is completed, this is, you are now in the code base DB level, okay? So once you have the design level here, load cases, for example, once you prepare linear time history analysis, response spectrum analysis, ELF and modal, dead load, everything, then what you have to do is you have to run your analysis, okay? I already ran it, and you go to your, if you go here modal, or just if you go to, for example, cases, for example, for this case, if I go to 10 seconds, if I go to the 10 second of the earthquake, then if I check it, it will give me the deformed, you see? This is a deformed shape at the 10 second of the earthquake. If you go to 20 second, for example, it will give me 20 second of the earthquake like this. And what you can do is, because you need the 40, 50 second response, you have to go to here and you have to create video, okay? Create video and multi-step video, and it will give you something. Because sharing is very difficult now. I had video, okay? I record the video for you, and it will show you the moment the shear force, everything change with minutes, okay? Even each second. So that is you are now in the linear analysis, okay? So you can check for example, the moments like this. You can check the shear force. You can check everything you need here, okay? For different part of, for example, for ELF, you can check the moment, okay? And you can go to, for example, response spectrum in the X direction. You can check the shear force. So this is, you are now where? In the elastic analysis. Once you are in the elastic analysis here, okay, what you do, you go to the, okay, what you do now, you have to go to the design part, okay? You have to go to here, design, still design, then here, start the design, check of structure. Then you have to design your sections, okay? You have to design your sections. Because why I'm designing now? You will get the reinforcement detail, okay? Before you go to nonlinear modeling, you have to know the section and the reinforcement of each, your shear wall, your beam, your column, okay? Then the program will use that as a capacity curve, okay? As you can see now, for example, it's finished already, and most of the beams, the columns are passed, but some of the columns are, you see, fail. So what you have to do, you have to go back again here, you have to change the sections, and you have to run again. But this is, for example, if you go to the elevation side, and if you go here, just to show you, you see, this is the area of steel. If you go here, it will give you the area of steel, okay? And some of the sections are out of sections, and it will give you major reinforcement and minor reinforcement. Once you get this information, then this information will give us a capacity for your nonlinear model. So now let me go to stop sharing. I have to share another also. Go share, window. Now, I have to go, I think this one. I think this one. Wait. Stop sharing. I have to go to share. Also this one. And let me go here. Sharing is post. Wait. You will need to go back to the window you were sharing to resume. Stop sharing. Okay, great. Share. This one. And you will need to go. I want to show you the nonlinear model. I don't know. It says you will need to go back to the window you were sharing to resume. This one is what? Can you stop sharing?
It is, another screen is being added. It's just blank at the moment. Unfortunately.
Take participant of screen. I want to share this screen. How can I get them? Some screen is shared now. I want to. Wait. I want to show them, not screen. I want to. Wait, stop sharing. Share window. Wait, share. Yeah, I say share window, and I want to share, include sound, and I go here. But I don't know, it's not coming. You will need to go back to the window you were sharing to resume. It says like that.
I'm not too sure what that. I know it came up earlier. I'm just not too sure what that means, unfortunately.
Yeah. What can we do? Add background, or I say window. I say.
Dr. Arte, is there a way that you can possibly provide our attendees with the links to the ETABS so that they're able to see these on their own PCs or at their own time? Because currently we're about 25 minutes over time, so we will really have to wrap up the webinar shortly in order to meet the time frame. Is it possible that they can view ETABS somewhere else and you can provide them with this information? Because I do know that we will be providing them with the slides that you have sent to us.
Yeah, I'll send you some videos because I record them, especially if we have just 5 minutes. I don't know if I can show them the nonlinear modeling, it will help them, you know. So
I understand.
what is the problem for window? This
yeah,
one.
I understand. So what Jasmine is saying is that you are showing us that you are sharing a window. We can see a second screen. However, there is no content displayed on there. So I unfortunately cannot see the view from your end as to what you can see with your windows, but there we go. So just bring up the presentation on the screen and then we'll just bring you there.
This one,
There,
yeah?
it's all there. Yeah, can you see that?
Okay, they can see. Yeah, okay, let me do it here. Okay, so what we can
Okay.
do now, just 5 minutes. Okay, just once you finish your linear, now I can go. They can see, yes, because
Yes,
the
we can
most
see.
important part is this one. Okay, so what you do once you finish your linear analysis here, you just go and unlock your result. Okay, unlock your result. Once you unlock your result now, for example, what you do, select, you go and you just property, frame section. For example, let me select all the beams, okay? We have this one, select, we have this one, select, we have this one, select, and we have this one, select. So all the beams are selected now. So what you do, you go to assign frame hinges, okay? You go to hinges and this is auto. Just let's assign, for example, 0.1. Add. Okay, now you see that all the ASCE41 file will come. Okay, then you choose 4117 and you're gonna choose beam flexure and you're gonna choose M3 and you're gonna choose here the load, but this has another, but you're gonna choose from here and you're gonna choose, you see, reinforcement ratio from design and drop. Then once you say okay, it will apply in one end, and in the another end of the beam, again you will add, and the beam, everything is the same, and you're gonna apply. Then when you say add, now you are changing your linear analysis into non-linear analysis, okay? So as you can see here, if I go here, you see the hinges are already added. Again, I go to here column, okay? So what you can do, select, and by frame section, property, frame section, and you go to the column side, you just select column, and this is all the column. Then you go to assign and you go to frame hinges. And now we're gonna assign here 0.1, add. At this time, instead of steel, you're gonna choose your column, concrete column, and the degree will be PM to M3, and this everything is the same. And you go through here and you're gonna say okay. Again, in the other end, 10%, just add, and you're gonna the same thing, okay. Then okay. Okay. Then everything is, you see, in the column also, it is assigned. The last one is just go to select and by frame section property and this wall section, and you're gonna choose all the wall, select. Now, when you assign here shield, you have to, you see, reinforcement from wall hinges. So you can say from design, okay? Then apply. This is two-way application. Then again, you just go to select, okay? Get previous selection, okay? This is then what you do, assign shell, and you're gonna assign wall hinges. In the wall hinges, we're gonna assign PM3, PM3, okay? That this is fiber hinge modeling, then okay. Now you change all your linear analysis into nonlinear analysis by plastic hinge modeling for column and beam, and you change fiber hinge modeling for column, for shear wall. Once you change this one, you go to define load cases. As you can see, load cases now, we have only linear analysis, yes? So we have to change it into define load cases. Then you have to add new load cases. Instead of, for example, this is nonlinear load case, nonlinear, okay, like this, nonlinear load case. And you have to say here, nonlinear, this times 3. And from times 3, you choose nonlinear response history. And here you can start from 0, or but you have to add there nonlinear, because for now I will start from here. And here you have to change acceleration U1. Then you have to choose from here the type of earthquake you are going to use, and you have to use the scale factor here, okay? 980. Like this. So all this, it will get from model and mode, you have to go here, you have to see 0.05% damping, and the nonlinear parameters are already from there. Then you have to say, okay. Okay, but you have to add also in the, you have to add also in the y direction, acceleration, U2, and you have to go there, and you have to use 2 also, and here you have to put scale. So once you do this, you say, okay, now you have nonlinear load case, okay? So if I say, okay, and if I go to display, no, analyze, set load case. So in the set load case, let's run only this nonlinear dynamic analysis, okay? This do not run, this do not run. All this, we don't have to run. Okay, like this. All should not run here. The only thing I want to run is nonlinear. So once you do this, just say run. Now your structure has a capability to check the nonlinearity, because you assign the force deformation curve from your linear analysis. Then you have to change your linear model into nonlinear model, and you have to give the capacity curve. And once you give the capacity curve, then you have to load your load case, and you have to run your building. Okay. Now after the analysis, it will give us the capacity for each hinge. Will give us the limit, okay? Each hinge will capture the capacity of the building, okay? So it's already done. Now 87 and 88. Basically, performance-based is very deep knowledge. We cannot finish it in 1 hour. We need one day even, okay, to go through the basics of each concept. But what I'm doing in this webinar is to give you a general overview. What is performance-based analysis? How to change the model from linear to nonlinear? What is force deformation curve? What is plastic hinge modeling? What is fiber hinge modeling? And how to define loaders and something like that. Now, at the end of this webinar, you may not be specialist in PVD, at least you know the idea behind. And at least you know the idea that code-based design is not the adequate way of designing a building, but performance-based is the most advanced, and it will give you every information about your building. Okay. I mean, there was a lot of things I was recording, and even I had linear models. I want to show you everything, but this one is also completed. So once the analysis is done, as you can see, now the analysis is done, okay? So what I'm going to do now, I will go to here, okay? It's done already. So I will go to deformed shape. For example, let me go to lowercase. This is the only thing. So now each time, okay, for example, 1 second, let me go to 10 seconds. At the 10 second, okay, let me go at the 10th second. What is the response of the building? You see, at the 10th second, the building is, you see some hinges are here. For example, just 1 minute, guys. 1 minute. This shear wall, let me remove. Okay, let me remove this shear wall. I want to show you. You see hinges, some hinges are already at the 10 second, some hinges are already here. If I go to, for example, 20 second, sorry. If I go to at 20 second, for example, apply. You see, at the 20 second also, some hinges are already formed. Maybe we have until 10. Okay, we have until 10 seconds. So this is what we can see, and you can display, and you can go to, for example, story plots. You can see, for example, for mode type, or this is lowercase for us. So what I want to see is everything, like displacement. I want to see this diaphragm. I want to see story moment. But this one, the time I have to choose, because the output is at the time, and the time I want to see at the 10, the end of 10 second, okay? So you see the reaction is coming. So everything, maximum story drift, and shear also, and moment also, and story stiffness also, okay? So in this way, you can check everything. And if you want to see also display the cumulative also, you can go here, and it will give you the cumulative responses, okay? Displacement, drift, shear, and overturning. And you can choose here, and from this load and the step, like 10. You can choose the step, okay? And it will animate also. If you want to animate, then it will give you the animation, okay? You see? It will animate, and it will give you the responses. So in this way, you can check, but the most important thing is we change our structure from linear to nonlinear, and it will, now that your building has a capability, okay? Your building has a capability to check the hinges, okay? This hinge override. So if you can go, now your building has a capability to check. And one thing I want to show you, just go to define, and as you can see, material section, if you go to here, everything what the hinges which are created will come here. So everything what we generate for beam, column, everything is here. So if you go here, and if you modify, and if you go here, as you can see, all the moment curves and the IOLS and CP curves will be given here from ASCE curves, okay? And you can see this is 1, because what you do is the material start from the yielding moment, okay? It will not start from zero. They have MY, okay? This MY, the yielding moment, will be divided by the actual applied demand moment, and it will become 1. So the software, it doesn't need to know the elastic responses, okay? It will start from non-linear MY yielding point, and it will go like that. So this is a force deformation curve, and the hysteresis and everything. If you go to, this is for the beam, and if you go to for the column, this is the hinges created for column. So as you can see, you see, this is what I told you. PM, M1, M2 curves will be here a lot, because depending on the actual force and the plane which you are in, for example, if I go here, it will go. You see, in the column, there is a lot of planes. The force at PM, M2 and M1 will apply. So depending on the PM, M2 axial force, it will generate the moment rotation curve of your column. So in this way, you can go ahead and check. But one thing I want to show you for your information, if you go here, the hysteresis type is isotropic, okay? But for column, for concrete, we have another type. So what if you want to have, if you assign your structure with automatic, you don't have the chance to change. So what you can do is you go here, you just convert it user defined. You see now it is user defined. So if it is user defined, now if I go here and if I am here, now I have a chance to change it from isotropic, kinematic, Takeda model, pivot, and everything. So I can change it to Takeda model and I can change it because Takeda is very good for concrete types. Anyways, thank you so much, guys. In short, this is PBD, and the whole idea of PBD is it will give you you can design your building with performance-based design, or you can retrofit also the existing designs. And this is somehow the procedure of performance-based design. And sorry, I took a lot of time. Thank you so much, guys. Yasmin, can you hear me?
Yes, thank you so much. Just bear with me one moment whilst I share the slides. So which slide are you up to now? Or are you finished?
Wait, it's coming. It's coming. Thank you for joining. We will, yeah, this in the first page.
Yeah, no. I'm just wondering because I know you got up to here. So have you discussed all of this?
Yes, the other one is results. No need. All of them are just results, which
Okay,
we get from our analysis, just for the participants to see what result they expect from the performance-based analysis, because we have almost all analysis types. Alpha analysis, response spectrum analysis, linear time history analysis, nonlinear time history analysis, pushover analysis, nonlinear time history analysis, and nonlinear response history analysis. So this webinar give you almost everything. And once you do your analysis through all these things, then you are good to go, okay? And in the first page, we give you already 4 papers we published already in EIT. So these papers will show you the detail about what is performance-based design, the results, everything. So you can, in the first page, there is 4 papers which are published as part of EIT. So you can go through them. I hope you get some idea about performance-based as much as I can. I try to show you despite some problems. Thank you so much, our participants. Thank you, Jasmine.
I'm just going to, obviously, thank you everyone for joining today. I'm just going to take you off screen for now. Turn on my camera. Beautiful. So thank you everyone for your patience today. What covers this topic? So the Professional Certificate of Competency in Building Information Modeling, BIM, sorry. Professional Certificate of Competency in Green Building Carbon Management in Infrastructure, the Advanced Diploma of Civil and Structural Engineering, the Graduate Certificate in Civil Construction Management, the Online Bachelor of Science in Civil and Structural Engineering, and then the Graduate Certificate in Civil Engineering Structural. As you can see here, there are upcoming courses in relation to this, which is amazing. And then I have already shared the certificate of attendance link in the chat, which is amazing. And so now I'm going to pull you back onto screen. And then I'm going to also paste the question that somebody submitted. I've
This
pasted
one?
this into the chat. Yeah.
Okay.
Yes.
If the result obtained from the performance-based design indicates smaller column, cross-sectional area, and reduced steel reinforcement compared to what is required by the conventional code-based, would it be appropriate and acceptable to proceed with the performance-based result, or should we still adhere to the code-based requirement? Thank you so much. As you said, from our research also, what we get is the nonlinear time history analysis and pushover analysis result always lower than the response spectrum analysis and linear time history analysis. So the linear analysis result always give you higher responses. Okay, so it doesn't mean that you always get the higher results through nonlinear time history analysis and pushover. Even the response spectrum global response results, when you multiply it with overstrength factor omega, it will go far beyond the result of performance-based even. So even, for example, if you perform ASCE analysis and response spectrum analysis, the code says when you perform response spectrum analysis, the result is always lower than alpha analysis. So you have to magnify the result of response spectrum analysis until 80 and 90% of the equivalent loss spectrum. So you have to change the scale factor and you have to apply it again. So that is what the code says. So in short, your question, always expect lower result in the performance-based result. Thank you so much.
Thank you for answering that. You can see here where you can contact us, which is amazing. And then just to answer someone's question, we have many different webinars in different fields, so just keep an eye out for that. I hope you all have an amazing rest of your day, and thank you all for your patience today. And thank you, Dr. Abati. I really appreciate your patience as well. I hope you all have a lovely rest of your day. Bye for now.
Thank you so much. I really appreciate it.
Almost forgot to stop recording. All right. Bye for now.
Thank you.